All right, slope measures the steepness of a line. Slope, the definition of slope. Slope is the measure of steepness. Yes. You can sit in Marie's spot right up there. Slope measures the steepness of a line. Slope measures the steepness, and steepness is the incline. Slope measures the steepness or the incline of a line. Something can be very, very steep. If you think about climbing a mountain, that would be a very steep climb. Or something can be mildly steep, right? Not very steep. If something is not very steep, it's at a very slight tilt. Slope measures the steepness of a line, the tilt, the pitch of a line. Slope can be. So let's say can be. Slope can be positive. The slope of a line could be positive. The slope of the line could be negative. A line could have a slope of 0. There could be no steepness to it. The slope of a line could be undefined. It could not exist. It could be impossible to measure. So let's draw little clues to ourselves. Again, positive, negative, 0, or undefined. Slope can be positive, slope can be negative. Slope could be 0. There could be 0 steepness. Or slope could be undefined. Impossible. Again, if you were riding a bike, this is a positive hill. This is a negative hill. This is 0 hill. And this is an impossible hill. Undefined. Slope can be a regular fraction. (1/2), (3/4), 9/10, 2/3, (1/3). A regular fraction. Slope can be an improper fraction. What does it mean, improper fraction?
Like 5/4, right?
What does that mean? Yeah, 5/4 is an improper fraction. What does that mean?
Over 1. Like more than 1.
So it's greater than 1? Like if you simplified it, it would be greater than 1? Gabe, what else? The numerator is greater than the denominator. Your numerator, your top number, is larger, greater, bigger than your denominator, your bottom number. And slope can be a whole number. Like 5 or -3. I guess that would be an integer, right? If it could be positive or negative. Slope cannot be. Slope cannot be. Slope cannot be. Slope cannot be a decimal. You can't say, oh, the slope of this is 1 over 2, 1/2. Oh, so I'll just put 0.5. No. And it cannot be a mixed number. There's a lot of cans. Slope can be a lot of things. There are only 2 knots. Slope cannot be a decimal. Do not take your fraction and make it a decimal. Slope cannot be a mixed number. It must be improper. If it can simplify to a mixed number, don't. Keep it improper. All right, slope. Here's our formula. Slope, when you're looking at a graph, is called rise over run. Slope on a graph is called rise over run. What direction on a graph do you think is the rise?
Positive.
What do you think? What direction on a graph is the rise, Ava? The Y. It's vertical. It's the Y, the change in Y. Vertical. Rise is vertical. What do you think run is? It's horizontal. It's the change in X. So to find our slope today, we are doing rise, the vertical change, over run, the horizontal change. Slope is rise over run, vertical over horizontal. Change in Y, because the Y in a graph is the vertical, over the horizontal, which is the change in X. Here are the steps we're following today. We start at the bottom ordered pair, which is a dot. You start at the bottom ordered pair, or the bottom dot. Start at the bottom dot. That's just where we always start. And when you're at the bottom dot, you're going to count the number of spaces going up. You're going to count the number of spaces going up, which is the rise, until even with the top dot. You're going to count the number of spaces that you go up. That's the rise. Vertical. Right? Until you're even with the top dot. This is the numerator. What does numerator mean? Top. Top number in an ordered pair. In a fraction. Next, we turn the corner and count over to the top dot. Next we turn the corner and count over to the top dot. If you count to the left, it's negative. If you count to the right, it's positive. If you count to the left or backward, your run is negative because numbers on a number line to the left, the numbers get smaller. So that's a negative change. Going to the right on a number line, numbers increase, they get bigger, they're greater. That's a positive change. This is the denominator. And step 3 is to simplify. "37 is where we're going to do our practice, but right now I'm not going to take my time to glue. I'm just going to transfer over. We'll glue when we're done. These are our steps. Remember, slope can be and slope cannot be. Here are our steps. Now, ladies and gentlemen, the hardest part about counting slope is that you have to have precision. You have to be precise. People get overly confident because it's counting and they don't actually like put pen to paper and they just look at it and guess. Not guess, but they look at it and they make the wrong decision. So when counting slope, put pen or pencil on your paper. If you start at the bottom dot and you count up until you're even with the top dot, that means up 1, 2, 3, 4, and I stop. Because I'm even with the top dot. 4. My rise was 4. My run is to the right 2. So it's positive 2. My rise over run. What is 4 over 2 simplified? And can you have a whole number? Yes. The slope of this line is 2. Is this slope, is this a steep slope or a non-steep slope? This is a pretty steep slope. The closer your slope is to 0, the less steep it is. Number 2, start at the bottom dot and we count up. 1, 2. My rise is 2 over. My run is negative 2 because I went to the left. 2. 2 over negative 2 simplifies to negative 1. Ladies and gentlemen, what shape is being made by my slope? A triangle, and specifically what kind of triangle? A right triangle. People get lazy. and they count their slope like this. I know. Precision. You have to be precise. Number 3, bottom dot to top dot. Start at the bottom dot, count up. 1, 2, 3, 4, and we stop. Turn the corner, count over. 1, 2, 3, 4, 5. Can 4/5 be simplified? No, it is as simple as it gets. 4/5 is your answer. Number 4, start at the bottom dot. Count up. 1, 2, 3, 4. My rise is 4. How many do I go over? 0. If you put that in your calculator, do it. Simplify 4 over 0. It says divide by 0 error, doesn't it? You cannot divide by 0. If I had $4 and I wanted to give that $4 to 0 people, how many groups would I have?
None.
Because it can't be done. If I had $4 and I wanted to split this $4, I wanted to give these to 0 people. Could you do it? No. Because even if you said, well, Mrs. Long, you just keep it, how many groups do I have? I mean, I have one group of 4, right? I could give it to 2 people. I could give my $4 to 4 people. But I can't give it to 0 people because if I was going to give it to 0 people, it can't be done. Because if I keep it, I'm one person still, right? You cannot divide by 0. It is impossible to divide by 0. It is okay for 0 to be on top, but no way can 0 be in your denominator. 4 over 0 is what kind of slope? Undefined. Four over 0 is undefined. It's not a 0 slope, it's undefined. Again, riding your bike, you can ride up this hill. Riding your bike, you can ride down this hill. Riding your bike, you cannot go down a vertical line. It's undefined, it's impossible. 5, 6, 7, and 8 are a little trickier. Again, not much trickier, but a little bit because you have to be precise. You have to be precise. The problem with 5, 6, 7, and 8 is that they do not have dots on them. So you're going to put your own on them wherever you want, as long as it's really a point. So if you look, if I'm going to put a dot here, an ordered pair here, I put it there because the diagonal line is in the middle of those 4 grid boxes. It is perfectly in the middle. And then I can go right here and put another one. But on number 5, someone else's 2 dots could look different. Because are there more places to put a dot? Yeah. There are 4 more places I could have put it. But it doesn't matter because I'm going to get a fraction and I'm going to simplify it and we'll all have the same answer no matter what it looks like. As long as you are precise. If you make up a point, if you put a point where it doesn't belong, you're not going to get the same answer. So this up to and over what?
4. Negative.
There you go. -4. Which simplifies to 1 over -2, or -1 over +2, or -1 over 2. Doesn't matter where that negative sign goes. It can belong to the denominator. It can belong to the numerator. It can be in front of it. But only one negative, right? Don't make them both negative. That changes it. Because you guys, if I did this dot to this dot, up 1, -2. It doesn't matter where my ordered pairs, where my dots go, as long as I'm precise.
Wait. Did I put the -2 then?
Well, yeah, because I simplified this fraction to 1 over -2. And it's a negative slope, so one of them has to be negative. Number 6. Doesn't matter where you put them. Up to -4. These two lines have the same slope. Do you agree? Do they look like they have the same steepness? They're just in different locations, but they have the same steepness. What can you tell me about these two lines? What relationship do they have? They're parallel. They'll never intersect. Number 7. Where are you going to put your dots on number 7? Where do the ordered pairs go? Are there multiple choices or only one choice on number 7? There's only one way to do it. Here's one ordered pair. And here's the other. There are no other precise ordered pairs in this graph. What's your rise? 1, 2, 3. And 1, 2, 3, 4. Positive or negative? Number 8, I'm going to put my ordered pairs. My rules specifically say start at the bottom dot. Which one is on the bottom?
Both.
Yeah, there's nothing on the bottom, right? They're even with each other. So how many do I have to go up?
0.
My rise is 0. My run, my distance between them, is 4. What's the slope of this line? What's the measure of steepness? 0.